Scalable offline metrics for autonomous driving. A key question in developing driving models is, how do we evaluate them safely? Online testing in the real world is ideal, but costly, slow, and risky. So we rely on offline evaluation with pre-collected data. It's faster and safer. The problem is, offline results don't reliably predict real-world behavior. Small dataset errors can compound into real collisions. In our work with more realistic benchmarks, we found this offline-online gap is even larger than previously reported. The key prior work introduced the TRE and QCE metrics to predict online success. However, its validation was limited to simplistic towns. It only measured the final success rate, and it only considered the steering action, ignoring the complexity of holistic driving performance. We hypothesized that the most dangerous online failures occur in rare or challenging situations, precisely when the model is most uncertain about what to do. Standard metrics treat all errors equally, whether the model was confident or not. So we propose a new metric to fix this, the uncertainty weighted error, or UWE. First, we estimate the model's epistemic uncertainty for a given decision using Monte Carlo dropout. This gives us an uncertainty score. Then, as the equation here shows, we use that score to weigh the prediction error. In short, errors made with high uncertainty are penalized much more heavily. To validate UWE, we built a comprehensive setup spanning both simulation and real-world tests. In simulation, we evaluated 82 model variants in Carla on the challenging longest 6 benchmark, 36 urban routes averaging 1.5 kilometers each. For real-world validation, we developed 2 physical platforms, a modified RC car with a Jetson Orin and wide-angle camera, tested outdoors on long routes, with naturalistic challenges like uneven terrain and pedestrians, and an indoor platform focused on targeted routes to test specific challenging scenarios. In simulation, the scatter plots show our UWE metric has a negative 0.69 correlation with the online driving score, showing stronger correlation with less spread as compared to prior metrics. The radar chart confirms UWE is the superior predictor across all 9 online performance metrics, including collisions, traffic infractions, and route completion. In the real world, on naturalistic routes, the radar chart on the left shows our uncertainty-weighted metric shows the strongest correlation with most online metrics, including success rate and route completion. While on targeted scenarios, the chart on the right shows it again has the strongest correlation with all online metrics. Here's a simulator example showing real impact. The top model, best by QCE, fails to detect a crossing bicyclist and crashes, scoring just 7.7. The bottom model, best by our UWE metric, recognizes the danger, avoids the collision, and scores over 90. Here's another example showing a different failure, lack of progress. The top video shows the best model by TRE. It's overly cautious, brakes, and gets stuck at an intersection, earning a poor driving score of approximately 40. The bottom video, selected by our UWE metric, navigates smoothly and confidently, scoring over 90. This demonstrates that UWE better predicts online performance. Here, we see some examples of the real-world evaluation. First, let's look at a model that our metric predicted would perform poorly, one with a high uncertainty-weighted error. As it navigates the path and approaches the cones, we see it fails to stop and collides with the obstacle. In contrast, here's another model with a low uncertainty-weighted error. In the exact same scenario, it drives up to the cones and safely stops before resuming once the obstacle is removed. Finally, we also show some examples of a model with low UWE score handling challenging scenarios in an indoor setting. This confirms that our offline metric can successfully scale to the real world. Standard offline metrics poorly predict real-world safety. Our UWE metric weights errors by model uncertainty, and it achieves greater than 13% higher correlation with online performance. We validated it in both complex simulations and real-world settings. Thank you for watching.